In this class, we'll use our graphing calculator quite a lot. I happen to have a TI-84 here. If you have a TI-83, that would be fine too. They work practically exactly the same way. What I want to do today is go through some basic skills that you should have on your calculator, and then I'm going to give you an assignment sheet to do and turn into me. First thing we use our calculator for, of course, is to do some arithmetic. It does standard things like you would think. I mean, if you go 5 plus 6, works out just great. 9 minus, or 7 minus 9, so on and so forth, negative 2. You might notice that there are two buttons that look like minus. There's one here, and there's one there. This one is used for subtraction, where this one is used for negative numbers. If I wanted 8 times negative 3, I would type it like that. If I typed 8 times negative 3 and I used the wrong minus button, the calculator tells me something's not right there. Okay? Okay, so let's take a look at some of the problems on this sheet here. Here's one of the things I think you're going to like the most about this calculator is what it can do with fractions. If I take 1/2 plus 3/4 minus 5/8 and I hit enter, it does give me a decimal. General rule of thumb is if a problem starts with fractions, your answer should be a fraction, not a decimal. Math, enter, enter, and your calculator will turn that into a fraction for you. That's 5/8. Okay, very handy feature. Next problem. Before I do this one on the calculator, I'm going to do it by hand because I'm going to show you a real common mistake that people make. Square root of 64. You might happen to note that the square root of 64 is 8. So that's 5 plus 8 over 8. 5 plus 8 is 13 over 8. Now, what I will see a lot of people do on the calculator is they'll type in 5 plus square root is right there. You got to push the second button and then the square root of 64, and you're going to move out of the square root, divide by 8, and the calculator will tell them the answer is 6, and they're rather confused as to why they don't get the right answer. Here's the thing: the calculator follows the order of operations 100% of the time. So according to the order of operations, the calculator looks at this and says, first thing I do is square root. So it does square root of 64. Then it says, I see a division and I see an addition. Division comes before addition. So the calculator does square root of 64, calls that 8. Then it does 8 divided by 8. That's 1. 1 plus 5 is 6. So here's a general rule of thumb. If you have more than one thing in the numerator or more than one thing in the denominator, put them in parentheses. Okay? That'll help always get the order of operations correct. So what I should do is I should write parenthesis 5 plus square root of 64 divided by 8. And another thing I'll mention real quickly, I'm using a TI-84 with the newest operating system. If you have an older TI-84 or if you have a TI-83, when you hit that square root button, it puts a parenthesis in there. You need to make sure you close that parenthesis too. Okay, now I hit enter. Calculator again gives me a decimal. Since I started with a fraction, I'm going to try to turn it into a fraction, and I do get 13/8. Alright, the next problem, again, very common mistake. People will go 3 divided by 8 divided by 15 divided by 16. And again, if I'm the calculator, I see a whole bunch of divides. So I take 3, then I divide that by 8. I take that answer, I divide it by 15, and finally I take that answer, divide it by 16. But again, we know from dealing with fractions that that's not what we want to do. In order to divide fractions, we know we have to flip and multiply. So think of this way. Think of this as 3/8 divided by 15/16. So once again, we have more than one thing on top and we have more than one thing on bottom. So to type this in correctly, I really need parentheses. I should put 3/8 divided by 15/16. And then the calculator will take 3 divided by 8, it'll take 15 divided by 16, and then finally it will divide those two answers. 0.4, again, I can convert that to a fraction, 2/5. Alright. Exponents. There's a button specifically for squaring, right here. Same button I used earlier to get the square root button, square root symbol. For other exponents, you're going to use this little caret button, it's called. So we're going to have 48 caret, and again, if you have an older type calculator, it doesn't put the little box there, it just puts the actual caret symbol. -3/4. And again, if you're using an older calculator, when it puts a little caret there, you have more than one thing in your exponent, so you would need to put your exponent within a set of parentheses. This is one of the advantages of the new operating system. Let's see if the calculator can convert that to a fraction. It can't. Okay, so some things are not fractions, some things are what we call irrational numbers, and that's the best we can do. So on something like this, it would probably be okay to round off to about 4 decimal places. So I'm going to write that as 0.0548. Okay, this problem. This looks like something called the quadratic formula, if you're familiar with that quadratic formula. If not, you'll see that later on in this course. I'm going to do this one twice. I'm going to do it 2 different ways. First, I'm going to do it kind of the way I would do it if I was doing it by hand. And what I mean by that is, if I had to do this by hand, if I didn't have a calculator, I would start using the order of operations, doing the thing under the square root. So I'm going to do that first. That's 5 squared minus 4 times 6 times -2. I don't need to type in those parentheses that are there, but if you want to, you can. So that's 73. Now what I want to do next is I want to take the square root of 73. And the way you can do that is square root. And then of course you could type the number 73, but if you had an uglier number, you might not want to have to retype it. If you had some ugly decimal like we had up here, there's an answer option here, which is very helpful. Second answer. So now I've taken the square root of 73. So I've done the square root of the whole thing. Now I would need to do -5 plus that answer. So -5 plus, and this is a great example, I don't want to have to type that whole number over again. I use that answer option. And finally, I need to take that whole thing and divide by 2 times 6. 2 times 6 I'm going to do in my head, that's 12. If I just hit the divide button, the calculator will automatically put the answer there. So if you hit any divide, times, minus, or plus buttons, the calculator will assume you just want to take the last answer and do something else with it. My answer here would be 0.2953. And you can try turning that one into a fraction if you want. It won't work. Now, I want you to compare that to typing this in all at once. If I'm going to type this in all at once, first thing I have to notice is I have more than one thing on the numerator. So I need a set of parentheses for my numerator. So that's -5 plus the square root. Now I have more than one thing underneath my square root, which means I need a set of parentheses for that too. 5 squared minus 4 times 6 times -2. Close the parenthesis for the square root, and then I got to close the parenthesis for the numerator. Divide by 12. And if I didn't write it as 12, if I wanted to do 2 times 6, I would have to have that in parentheses also. So doing it all at once is nice. It's quick and efficient if you're very good at understanding the order of operations and recognizing how you got to put parentheses in. Which way you should do that is up to you. Whichever way you think is easier for you to understand is the way you should do it. Okay, well, now, of course, all calculators are good at arithmetic. The advantage of a graphing calculator is the other things it can do, in particular graphing. So we're going to do graphing in just a minute. Now if I asked you to graph y equals minus 2x plus 5, one of the ways you might do it is to build a little table. You might plug numbers in. You might plug in negative 2 and say negative 2 times negative 2 is 4. 4 plus 5 is 9. Negative 2 times negative 1 is 2. 2 plus 5 is 7. So on and so forth, and you might fill in that table. Well, the good news is your calculator is wonderful at making tables. So I'm going to go to y equals, and I'm going to type in my equation. Negative, make sure you're using the right minus sign here. It's this one. Negative 2x plus 5. And then, notice the calculator has table right up here on the same button as graph. So I'm going to go second table. And it's starting with my table at 0. And going by ones, 1, 2, 3, 4, 5. If I want to plug in numbers like negative 2 and negative 1, I simply hit my up arrow a few times. Negative 2, negative 1, 0, 1, 2, and the calculator does a few more numbers for me. So let's see. These are 5, 3, and 1. Now, let's say I wanted to take that same equation and I wanted to plug in numbers like 40 and 45 and 50. And we will be doing this later in this semester. Think of maybe X stands for years. So we're looking at what happens in 40 years, 45 years, 50 years, and so on and so forth. I could sit here with my down arrow and go and go and go and go on. I don't want to do that. Not very efficient. What we're going to do instead is we're going to go into this table setup menu, which is on the same button as window. Second table setup. And there's a couple options here. What I'm going to do is I notice I want 40, 45, 50, 55, so I'm going to tell my calculator start at 40. And then delta table, I notice these are going by 5s. 40, 45, 50, 55, so I'm going to tell it go by 5s. And now when I go back to my table gives me exactly what I want. It starts at 40, 45, 50, 55, so on and so forth. I'm not going to write down all the numbers on my sheet of paper here, but you can see my answers: negative 75, negative 85, negative 95, so on and so forth. Now, let's say you wanted to have an equation and you needed to plug in some random numbers that aren't related like they were here. They don't differ by 5. Again, the calculator can handle this for you. You go second, table setup, come down here and take the independent variable, that's your x variable, and change it to ask. And personally, this is the way I usually have my calculator set up. I usually leave it in this menu. When I go to my table, there's nothing there. But notice it's got x equals and it's got a blank there. It allows me to type in any number. So I can type in negative, make sure you use the right minus button there. It's this one, by the way, negative 18. And it tells me the answer is 41. Hey, plug in 23. Tells me the answer is positive 41. That was a happy coincidence. I just picked those two numbers at random. I didn't expect that to happen. 106. 5/4. Notice when I type in 5/4, it converts it to a decimal. That's okay, I suppose. 12.43. So on and so forth. I can type in any numbers I want. Okay, so calculator, wonderful at building tables. The other thing it's wonderful for, of course, is graphing. I already have minus 2x plus 5 typed in. I hit graph, and that's a very strange looking graph. And what's going on here is my window, what's known as the window, is set up poorly for this problem. What I'm going to do to change my window is I'm going to go zoom, and I'm going to start with number 6. I always like to start with zoom number 6. What zoom number 6 does is it makes it so that my graph goes 10 units to the left, 10 units to the right, 10 units to the left, 10 up and 10 down, and each little tick mark in both directions is worth 1. So if I'm using my calculator to draw a graph, I draw this graph on my piece of paper, but then it's important that I describe to the reader what my window is. And I can see my window by pushing the window button, and I know what it is in this case. I'm going negative 10 to 10, because that's what I told you it was. Negative 10 to 10. And then my scale, my x scale is 1. Each little tick mark I told you on the graph was worth 1 point. Okay, so not only do you have to draw a graph, you also have to give a scaling so that the person knows what they're looking at. For example, if I were to ask you to graph y equals 3x squared plus 11, y equals 3x squared plus 11, when I hit the graph button, absolutely nothing shows up. Now, that doesn't mean that there's no graph. What it means is I can't see it on this window that I'm looking at. Again, my window's going 10, 10, 10, and 10. Well, think of what happens if I plug 0 in here. If I plug 0 in, I get 3 times 0 plus 11, that's 11. So I've got the point 0, comma 11. I'm up off the top of the graph. If I plug 1 in, 1 squared is 1, 1 times 3 is 3, 3 plus 11 is 14. Again, I'm up off the graph. So what would be a good idea here would be to go to the table and plug in numbers like -2, -1, 0, 1, and 2, and take a look at these y numbers. I notice my smallest y number is 11, and my y's are getting bigger, which tells me if I want to view this graph, I need to go higher than 10. To go higher than 10, push the window button. I think we're okay with our x min and our x max going from -10 to +10, but we need our y's to go higher. Right now our y maximum is 10. So I think I would come down here and I would change it to something, maybe 50, because I noticed when I plugged 2 in, I was already up into the 20s. I was already getting pretty big. Now this is my personal opinion. If my y max is going to be 50, I like my y min to be -50. I like it to be symmetric. And then my scaling. If I'm going to go all the way up to 50 here, I don't really want the calculator having each tick mark be 1. I think each tick mark being 5 would be more reasonable, to go 5, 10, 15, 20 to get up to 50. Let's take a graph. Alright, so we get that graph. Now what you need to recognize on this graph is these tick marks here go 1, 2, 3, 4, 5, or these tick marks on the y are going 5, 10, 15, 20. And unless you tell the person who's reading the graph that that's what's happening, there's no way that they're going to know. So it's important when you draw a graph that you give your window. Give the person the scaling so that they know what's going on and what they're looking at. Alright, the next one. Again, the next one, you got to be careful with order of operations. You have more than one thing on top, more than one thing on bottom. You need parentheses. X plus 1 divided by x minus 3. Again, this is my personal preference. I don't hit the graph button. I always go zoom number 6, so I know where I'm starting. I know I'm starting with this going 10 up, 10 to the right, 10 down, 10 to the left. And, you know, I take a look at that and say, hey, that looks okay. I don't think I need to change my window. So I go ahead and I draw the graph, giving my window here, -10, 10, 1, -10, 10, 1. Oh, the X resolution thing, you might have wondered about that. The X resolution tells the calculator how many little dots it should draw and connect. So when your X resolution gets bigger, you get a less accurate graph. So you notice this one doesn't look as good. In general, just leave that X resolution at 1. Don't worry about it. With X resolution 1, things usually come out pretty good. Alright, so go ahead and draw that graph on my paper here. Looks kind of like this. And like that. Alright, now the last one. Y equals 0.002 x squared minus 0.015 x. Zoom 6. I see a little something. I saw a little something draw right there. You can see it's a little thicker on the axes, but that's really not a very good picture. So again, I think what I need to do is take a look at my table and see what kind of y numbers I'm dealing with. Looking at my y numbers here, I notice that my y numbers are very small. 0.038, 0.017. So, on my graph, my ticks are going 1, 2, 3, 4, 5, but my graph is only 0.013 up in the air. So this time I need to change my window. I don't want my graph to go all the way to negative 10 to 10. That's way too big. Negative 1 to 1 might be enough. And then I would make my y scale be 0.1, so that when it draws the graph, it's going to go 0.1, 0.2, 0.3 to get all the way up to 10. All the way up to 1, I mean. Okay, that's better, but I would say still not great, because it's kind of hard to tell what's happening here. It looks like it's dipping below the axis a little bit and maybe coming back up. It also looks like I might want to go a little further to the right to see what's happening here. So I'm going to go back and change my window. I'm going to make my x's go negative 20 to 20, which means I want to double that. And I guess I don't want this to be quite so high even. All the way up to 1 was still too big. So maybe negative 0.5 to 0.5. Try that. Oops. Bad y scale. Because I'm going 0.01, 0.02, 0.03 try to get up to 0.05. That's too much. I can go back to 0.1, I guess. Alright, so now I see a graph that I'm kind of happy with. I can see I'm getting a graph that's a parabola. Alright, so again I got to write down my window here. Negative 20 to 20, step 2. Negative 0.5 to 0.5, step 0.1. So the moral of the story is there's no single window that's going to work for all graphs. You sometimes have to kind of play with them until you get a picture that looks acceptable, and what's acceptable is hard to explain, but we'll see more about that as we go along. Alright, 2 more skills we want to talk about. One is using the calculator to solve equations. There's 2 different ways to do this. I'm going to go back to y equals and type in x squared minus 5x minus 6. If your equation is like this one, where it's already equal to 0, all you need to do is type in the one equation and draw the graph. Again, to draw the graph, I'm going to go zoom number 6 to go back to my standard window. And I see that there are 2 answers. There are 2 places where this graph has a height of 0. It's right there and right there. To determine these 2 spots, I mean, well, I can take a pretty good guess here. It looks like one of them's at negative 1, and it looks like the other one's at about 5. But to determine that for sure, we're going to go into this calculate menu on the trace button. Second, calculate. And we want to determine where that equation is 0. Enter. Okay. First off, we have to decide which one we're going to find. Are we going to try to find this one first or that one first? Let's go with this one. The calculator is asking me for a left bound. What that means is I have to move the cursor, which you can see is flashing right here, a little hard to see. I need to move the cursor somewhere to the left of this point that I'm trying to find. So I use my arrow and I move it to the left and I hit enter. Then it asks me for a right bound, which means I need to take the cursor and have it be over here somewhere, over to the right of this point where I'm trying to find. I hit enter, and then it asks for a guess. I get close, I hit enter, and it does indeed tell me x equals negative 1. To find the other spot, we would repeat. So I would go second, calculate, 0, and I would come over here. Cursor disappears, it goes down below the screen there. There it is. Again, I'm looking for this spot. I need to be to the left of it. I am. I hit enter. Then I need a right bound. I hit enter. You might notice the calculator draws these little arrows here for your left bound and your right bound, and your answer needs to be in between them. Guess, enter, x equals 6. So that's the first way. That's called the 0 method. The second way to solve is called the intersect method, and you more likely use the intersect method on a problem like this. Now what I could do is I could write this as absolute value of 9x minus 3 minus 7 equals 0. I could do some work by hand, move that 7 over, and then use the 0 method like I did before. It would work fine. Instead, I'm going to use what's known as the intersect method. The intersect method works like this. You go to y equals, and you type in both equations. You type in the one on the left as y1, both expressions I mean. You type the expression on the left in as y1, the expression on the right is y2. Alright, absolute value, that's kind of a weird one. The easy way to find absolute value in the calculator, I think, is to go to the catalog. And the catalog is on the 0 button. So I go second, catalog, and absolute value happens to be the very first thing. What the catalog does is gives an alphabetical list of everything the calculator can do. Absolute value is the very first one. Again, if you have an older calculator, a TI-83 or an older TI-84, it's going to write the letters ABS and then put a parenthesis. And you're just going to have to type in 9x minus 3 inside the parentheses. I go to y2 and I type in 7. I draw my graph. Okay, so where are those equal? Well, they are equal where the two graphs cross. So there's the absolute value thing, and there's the 7 thing. There are two answers, 1, 2. So what I want to do is I want to find where these two graphs intersect, and that's why this is called the intersect method. I go into that calculate menu again, down to intersect. It asks me, is this the first equation? Notice up here it's got y1 equals ABS. Yeah, that's the first equation. Then it jumps to y2 equals 7 and asks, is it the second equation? Yes. Then it wants a guess. Again, there are two answers, so I get close to one of them. I'm going to get close to the one on the left, and hit enter, and it tells me one answer is negative 0.44444 going forever. So x equals negative 0.4 with a bar over it. Repeat. Second calculate. Intersect method. It asks me, am I on the first equation? Yep, I'm on the absolute value one. Hit enter. Did it jump to the second one? Yep, hit enter. A guess. Hit enter. 1.1 repeating. Now, students usually ask me, why does it ask you y1 first curve, y2 second curve? Well, because, and this will happen later on in this course, it might be that we have more than two things typed in. We might have 3 or 4 things all typed in at once, and we need to make sure that we're on the right equations. Okay? Alright, so let's try that with one more equation. Again, this one, I would type in square root of x plus 2 and x minus 3. Draw the picture. And it appears as though these two cross at one point. Calculate the intersect. It asks me, am I on the first curve? Yep. Am I on the second curve? Yep. Make a guess. You really don't have to get all that close. The calculator will work it out for you. Looks like the answer is, let's call it x equals 5.79. Okay, the last skill we want to learn today, scatter plots. We're going to, in this class, look at a lot of data. We're going to do things with data. One of the first things we always want to do with data is graph it. So to graph data, I'm going to go to y equals, and I'm going to clear those two equations. I don't want them. I need to enter the data. To enter the data, I go second quit to get back to the home screen. I'm going to go into the stat menu. Stat, edit. So notice my calculator has list 1, list 2. My calculator has a lot of data in it. Yours might have data, it might not. If you have data, you want to get rid of it. To get rid of it, hit the up arrow to go to the top of the list, and then hit clear, enter. And it'll get rid of it all. I'm going to go over to L1, hit up to go to the top of the list, clear, enter to get rid of it all. Okay, I type my X numbers into Y1, 0, 1, 2, 3, 4. and I type my Y numbers into L2. 10, 25, 42, 53, and 70. So I have my data all typed in. Now I have to tell the calculator, draw me a picture of that data. And that's taken care of here in what's known as the stat plot menu. I'm going to go second, Y equals to get into stat plot. I'm going to turn it on. We have lots of different graphs we can draw. This first one is the one we want. This is scatter plot. The second one is what's called a line graph. It draws the dots and then it connects them with lines. So something like you would see in the stock market, maybe the graph all connected with lines. Histogram, box and whisker plots, all sorts of things. The first one is the one we want. We put our X's in L1, we put our Y's in L2, and then we have choices. We can use little boxes, little plus signs, or little dots to mark our data. Personally, I like the little boxes. Up to you which one you like. Okay, now again, a common mistake students will make. They'll hit the graph button and not much shows up. What you really want to do when you're drawing a scatter plot is hit zoom and go down, down, down to number 9, which is zoom to fit the statistics. And the calculator will figure out a nice window for you so that you can see all your data. So if you were graphing this on your piece of paper, you would make the little boxes here where they are, kind of like so, and maybe make them a little bit more accurate than I am. I'm just trying to do it for speed. But then, once again, you have to make this make sense, and you have to tell somebody what your window is. So this window is going on my calculator. It went from minus 0.4 to 4.4. And then on the Y's, it went from minus 0.2 to 80.2. So again, you need to give a scaling like that to let the reader know what this data really looks like. Without the scaling, this really wouldn't make a whole lot of sense. Okay, so there's basic skills you need with the calculator. I'm going to send you a homework sheet that has problems almost identical to these. You're going to work through and you're going to send that back to me. There are lots of little calculator videos. I'm going to create a button called Calculator Videos. So if you look at that button, there'll be videos there. It'll go through a lot of the same stuff, except it'll be split into specific things. So if you want to know more about solving using the zero method, there'll be a video called Zero Method, so you can watch just that video. You don't have to go through this whole long entire video again. Okay. Anytime you're having difficulties with your calculator, send me an email, let me know, and we'll try to get it worked out.